Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamu alaikum little kids. This is Shehroz Abdullah and today we are going to discuss class 9th physics chapter number 3 dynamics exercise. Now we are going to discuss. We will discuss all the MCQs with their solution manuals and all the numericals with their solutions we will do today. Let me recall the previous work. In the previous work we have discussed centripetal force, centrifugal force, their application and all the things we have discussed in the last lecture. And now today we are going to discuss with all the MCQs with their solution manuals. Let me read the statement of the first MCQs. What is it says? A 30 kilogram object is supported from a rope such that the tension in the rope is equal to its weight. The weight of the object is, okay, the right option is 249 newtons. Look, mass given to over here is 30 kilograms, G value is 9.8, weight is supposed to find, W is equal to mg, 30 into 9.8, you are going to get option number C, that is 249 newtons. Okay, come to MCQs 2. A force needed to produce an acceleration of 10 meters per second square, acceleration is given to you, that is A is equal to 10 meter per second square in a ball of mass 0.5 kilogram. Yes, mass is given to you, force is required, just simple. F is equal to ma, multiply both the terms 0.5 and 10 and get 5 newtons, right? And you will get D is equal to option number D, that is 5 newton. Okay, MCQs number 3. Ball A collide with ball B which is at rest. After the collision, which of the ball of the following condition is not possible? So right option is option number D, both ball at rest. This is the right option of MCQs number 3. Come to MCQs 4. What is the mass? Means M is supposed to find of a car that is traveling with a velocity of 20 meter per second. V value is 20 meter per second. V value is 20 meter per second and momentum given to you is 2,000 kilogram meters per second. Okay, we know that P is equal to mv, m is equal to p by v, p is 2,000, v value is 20, divide it and get 1100 kilogram. Mass value is 1100 kilogram. So fourth MCQ's right option is D, that is 1100 kilograms. Okay, an object at earth and taken to moon should have what? Should have option number fifth MCQ's option number C, right option is same mass, less weight. Okay, come to MCQs number 6. The unit of coefficient of friction is, it has no unit, right option is MCQs 6, right option is D, it has no unit. Okay, come to 7. It says the centripetal acceleration of an object of mass 1 kilogram. Yes, mass is given to you 1 kilogram and speed is given to you 6 meters per second and radius is equal to 3 meters. Centripetal acceleration is supposed to find A is equal to V square by R. Just put the value and get the answer, 12 meters per second square. So right option for MCQ 7 is B, that is 12 meter per second square. Come to MCQs A. How many times the centripetal force will increase if the mass of the moving of a body moving with uniform speed in a circle is doubled? Means if you increase mass of the body to double, so what is the effect on centripetal force? Look, if you increase, let m is equal to 2m, like you have doubled the mass, right? So how many times centripetal force increase? Let's understand. We know that F is equal to mv square by r. Okay, instead of this m we will write 2m. Okay, so we get that Fc is equal to 2fc, means a centripetal force will become double. Okay, let's discuss MCQs 9. Which of the following forces can act as centripetal force? So right option for MCQs 9 is option number D, that is all of these. Okay, now coming towards MCQs number 10. What does it says? In MCQs 10 it says that an empty suitcase is placed in the middle of a bus on its floor traveling at high speeds. When the bus brakes suddenly, the suitcase it slides forward. So right option is MCQs 10, right option is B, that is forward. Coming towards 11, in Newton's third law, the action-reaction pair does not neutralize each other because they act on different bodies. So MCQs 11, right option is B. Okay, now this was all about MCQs with their solution manuals we have discussed, right? Now we are going to discuss all the numerical problems. Let me read the statement of the first numerical. What does it says in the first numerical? It's let's discuss numerical number first. Let me read the statement. It says 1580 kilogram car is traveling with a speed of 15 meters per second. Yes, what is the magnitude of the horizontal net force that is required to bring the car to halt at a distance of 15 meters. Yes, mass is given 1580 kilogram, initial velocity is 15 meters per second. When the car will stop or halt, its final velocity will become 0 and distance is given to is 50 meters, right? Force is required, as we know that from Newton's second law, F is equal to ma, right? From in third equation of motion, let me find the value for A. 2as is equal to vf square minus vi square, and then A is equal to vf square minus vi square divided by 2s, right? So just put the value over here, so we will get F is equal to m into vf square minus vi square divided by 2s, right? Just put the values over here, you can get the answer, right? Okay, so you are going to get 1580 into 0 square minus 15 square divided by 2 into 50, you are going to get minus 3.55 into 10 to the power 3 newtons, right? Over here, this minus sign shows you retarding force. Negative is retarding force. Coming towards numerical number 2, a bullet of mass 10 grams, mass is given 10 grams, is fired with a rifle. The bullet takes 0.003 seconds to move through a barrel and leaves with a velocity of 300 meters per second. What is the force exerted on the bullet by the rifle? Okay, coming towards mass is 10 grams divided by 1000, you are going to get 0.01 kilograms. Okay, time is 0.003 seconds. Initial velocity was 0 meters per second. Why? Because bullet was at rest. Final velocity is 3 meters per second. We are supposed to find force. We know F is equal to ma, right? So just putting the values like m will be as it is instead of this A, we will put the value from first equation. Vf is equal to vi plus 80. Vf minus vi is equal to 80, dividing both sides by t. You are going to get A is equal to Vf minus vi by t. Just put the values over here, and after putting the values, you are going to get F is equal to 0.001 multiplied by 300 minus 0 bracket close and divided by 0.003. You are going to get 1000 newtons, right? So which is the right answer? Okay, coming towards numerical number 3, let me read the statement of numerical number 3. What does it says? It says a 2200 kilogram vehicle traveling at 94 kilometers per hour, mean 26 meter per second, they has already given to us. So initial velocity is 26 meter per second, right? Okay, can be stopped in 21 seconds by gently applying the brake. Mean if a driver applies gently the brake, so time will be 21 seconds, right? T1 value will be this much, right? So for gently, time will be 21 seconds. If it can be stopped in 3.8 seconds if the driver slams on the brake. Yes, time T2 value for slams on the brake is how much? 3.8 seconds. The average force exerted on a vehicle in both the cases. Okay, that is needed to find. Okay, mass is 200 kilogram, initial velocity is 26 meters per second, final velocity is 0, time value 21 second, and time value 3.8 seconds. So F1 find when the driver gently stops the car, F2 find when the driver slams in the car, right? Okay, so for part 1, F1 is equal to ma1, so F1 is equal to m as it is. Instead of this A, we will write Vf minus Vi divided by T1. Instead of A, we will write Vf minus Vi divided by T from the first equation. Just put the value over here, you are going to get F1 is equal to 0 bracket 0 minus 26 divided by 21. After that, you are going to get F1 is equal to minus 2.7 into 10 to the power 3 newtons, right? Negative sign shows retarding force. Coming towards part number B, what does it say? The same expression we are going to use. F2 is equal to ma2 and F2 is equal to m Vf minus Vi divided by T2. Just put the values and get minus 1.5 into 10 to the power 4 newtons. Okay, let's read the statement of question number 4. If you move 500 Newton current across a floor, to start the current moving, you have to pull with 230 Newtons, right? Horizontal force. Once the current breaks loose and starts to move, you can keep it moving at constant velocity with just 200 Newtons, right? What are the coefficient of static? Okay, what are the coefficients of static and kinetic friction, right? Okay, so normal force is given to you, that is 500 newtons, and static friction is given to you 230 newtons, kinetic friction is given to you 200 newtons. What is required? Coefficient of static friction and coefficient of kinetic friction, both are needed to find, right? For the first case, coefficient of static friction, that is mu s into Fs is equal to mu s into Fn, and mu s will be equal to Fs divided by Fn. Just put the values over there and get the answer. So mu s is equal to 230 divided by 500, we are going to get 0.46, right? Okay, for coefficient of kinetic friction, we know that mu k, Fk is equal to mu k into Fn, right? Mu k will be equal to Fk divided by Fn. Okay, so mu k will be equal to 200 divided by 500 and get 0.40, right? So this was all about numerical number 4. Let's discuss numerical number 5. Two bodies of masses 3 kg and 5 kg are tied to the string which is passed over a pulley. If the pulley has no friction, find the acceleration of the bodies and tension in the string, right? Okay, masses 5 kg and 3 kg, G value gravitational acceleration, that is 9.8 meter per second square, that is understood. We need to find acceleration and tension in the string. The formula for acceleration in the string, we have derived it. A is equal to m1 minus m2 divided by m1 plus m2 into G. Okay, just put the values over there. A is equal to 5 minus 3 divided by 5 plus 3 into 9.8 and get the result 2.45 meters per second square. Okay, finding the tension in the string, that is part number B. T is equal to m1 m2 G divided by m1 plus m2. Just put the values in the formula and get T is equal to 2 multiplied by 5 multiplied by 3 multiplied by 9.8 divided by 2 plus 5 plus 3 and get T is equal to 8.44 into 10 to the power 4 newtons, right? Coming towards numerical number 6. Determine the magnitude of the centripetal force exerted by a rim and car's wheel on a 40 kg tire. The tire has a 0.480 radius and it's rotating with a speed of 30 meters per second. Yes, mass is 45 kg, R value is equal to 0.480, V value is 30, Fc is needed to find. Fc is equal to mv square by r. Fc is equal to 45 multiplied by 30 square divided by 0.480 and get the result of Fc is equal to 8.44 into 10 raised to the power 4 newtons, right? Coming towards numerical number 7. A motorcyclist is moving along a circular wooden track of circus death well of radius 5 meter at a speed of 10 meters per second. If the total mass of motorcyclist and the rider is 150 kg, find the magnitude of centripetal force acting on him. Okay, radius is 5 meters, speed is 10 meters per second, mass is 150 kg, centripetal force is needed to find, and we know that the formula for centripetal force is Fc is equal to mv square by r. Just put the values in the formula, that is Fc is equal to 150 multiplied by 10 square divided by 5 and get 3000 newtons. Okay, coming towards numerical number 8, let me read the statement, last numerical of this chapter. Okay, a car of mass 1000 kg is running on a circular motorway interchange near Sawabi with a velocity of 80 meters per second. The radius of the circular motorway interchange is 800 meters. How much centripetal force is required over there? Okay, mass is 1000 kg, V is 80 meters per second, R is 800 meters, centripetal force is required, Fc is equal to mv square by r, and we know that the formula for centripetal force is Fc is equal to mv square by r, right? Just putting the values in the formula, Fc is equal to 1000 multiplied by 80 square divided by 800, you can get the result of Fc is equal to 8000 newtons, right? So we have done all the numericals with their solutions, with their answers, right? Let me recall to today's work. In today's lecture, we have discussed all the MCQs with their solution manual, with their right answers, with their right options. We have discussed, okay, and all the numericals of this chapter number 3, dynamics, we have done in detail. Okay, this was all about today's lecture. Hope you have enjoyed the lecture. Thanks for watching. Allah Hafiz, fi amanillah, jazakallah. We are going to discuss all the conceptual question of class 9th physics, chapter number 3, dynamics, right? Let me recall the previous work. What we have done in the previous work, we have discussed all the MCQs with their solution manuals, with their solutions, with their right options. We have discussed all the numerical problems with their details, solutions, right? So we have done all that. Right now we are going to discuss all the conceptual questions of chapter number 3, class 9th physics, dynamics. Okay, let's start. The first statement, let me read the conceptual question. What does it says? Why dust fly away when a hanging carpet is beaten with a stick? You know, when a hanging carpet is beaten with a stick, the dust particle fly away. What is the reason behind that? You know, initially the dust particles are at rest in a carpet. When we beat it with a stick, we bring them in motion by beating with a stick. But still the dust particle wants to maintain its state of rest, and finally it comes to motion because of inertia. Because of what? Inertia. Okay, so this was question number 1. If your hands are wet and no towel is handy, you can remove some of the excess water by shaking them. Why does this work? Okay, look, it says that when your hands are wet, you can remove some of the excess amount of water by shaking them. Why? When we shake hands, so our hands come in motion. The drops of water which are stick to our hands, they are at rest and they want to maintain its state of rest, but they cannot, and finally because of inertia they just come out of our hands, right? So our hands become dry. Okay, it says then why a balloon filled with air move forward when the air is released. You know, when we release a balloon filled with air, so the air inside the balloon pushes, okay, that is action force. As a result of reaction, the balloon moves forward, right? So because of action and reaction, according to third law, the balloon moves forward. Okay, then it says why does a hose pipe tend to move backward when the fireman directs a powerful stream of water towards fire? You know, when a fireman directs a powerful stream of water, so the hose pipe moves backward. What is the reason behind that? You know, the powerful stream of water moves in forward. This is action force. As a result of reaction, the hose pipe moves backward, right? So because of action and reaction in third law, the water pipe moves backward, right? Okay, let's come to discuss question number 5. What does it says? A car is stuck in wet mud. Some students on their way to class see the predicament and help out by sitting on the trunk of your car to increase its friction. Why does this help? As we know that when the car is stuck in mud, so what happens? The friction between the tires and the mud is less. Okay, the car cannot come out of the mud. What happens when the students sit at the trunk of the car? As a result of which the weight increases, as a result of which the normal force increases, as a result of which friction increases, and car can come out of the mud very easily. Okay, then come towards question number 6. What does it says? Why does friction help you walk? Is it kinetic friction or static friction? You know, we are walking on the earth as a result of friction. Okay, you know, the friction between the ground and the shoe sole provides a friction that enables us to walk on the earth, right? So do remember one thing, because of fractional force we walk on the earth. That is basically a kinetic friction. Okay, then coming towards question number 7, the parking brakes. If the parking brake on a car causes the rear wheel to lock up, okay, what would be the likely consequence of applying the parking brake in the car that in rapid motion? You know, when the car is in rapid motion, when we apply brakes, so the rear wheels are locked up while the front wheels are still moving, and because of inertia the car is skid. Okay, so this was all about question number 7. Okay, coming towards question number 8, what does it says? Let me read the statement. Why is the surface of conveyor belt made rough? To increase friction, the conveyor belt is made rough. Okay, coming towards question number 9, why does a boatman tie his boat to a pillar before allowing the passengers to step on the river bank? You know, when the passengers are coming out of the boat, what does they do? They push they push the boat with their feet with action force. As a result of reaction, they move forward, right? As a result, what can happen? The boat may move backward again to the river. That is why to avoid such kind of scenario, what does the boatman do? He ties his boat to the pillar before allowing the passengers to step on the river bank. Coming towards question number 10, it says in uniform circular motion, is the velocity constant? Is the acceleration constant? Explain. Do remember one thing, in uniform circular motion, velocity is not constant. Why? Because direction is constantly changing, right? Okay, it's always tangent to the circle, while acceleration is constant. Why? Because the body is moving in circular path. The acceleration over here is centripetal acceleration, and that is always directed towards the center, right? That is constant. So what we say, velocity is not constant while acceleration is constant. Coming towards question number 11, you tie a brick to the end of a rope and rail the brick around a horizontal circle. Describe the path of the brick after you suddenly let go of the rope. You know, when you are moving a stone tied with a rope on a horizontal circle, when you suddenly leave it, so the stone will move very tangent to the very tangent, very straight motion or very tangent motion to the circle, right? So this is all about. Okay, coming towards last question of this chapter. What does it says? Why is the posted speed for a turn lower than speed limit on most highways? You know, when the car is taking turn, so centripetal force is provided by fractional force, and we know the formula for centripetal force, that is Fc is equal to mv square by r. Okay, or here if you consider centripetal force is directly proportional to speed of the car. More will be the speed of the car, more will be centripetal force. Okay, if the car is moving very fast, means speed is fast, so centripetal force will be unable to provide accurate amount of exact amount of centripetal force will be unable to provide over there, and the car may skid. As a result, at the turns it is posted, please lower the speed. So which means you are decreasing the speed. When the speed is decreased, less fractional, less centripetal force is required to car for a car to take turn, right? So as a result, the car can move very easily, and the fractional force, less fractional force provides the less centripetal force. As a result, the car can take turn very easily, right? So we have finished chapter number 3, dynamics. All the things in that chapter number 3 is done. Okay, now coming towards, let me summarize today's work. What we have done today, we have discussed chapter number 3, class 9, physics, dynamics, all the conceptual questions one by one. We have discussed with all their justifications, with all their examples we have done. So hope you have enjoyed the lecture. Thanks for watching. Allah Hafiz, fi amanillah.